Hey, this is Mr. Ward, and I am doing a video key for Geometry Exit Ticket 19.3, Week 19, Day 3. So for 4A and 4B, you're going to need these theorems. They are stated in the multiple choice options, of course, but just a reminder, all radii of a circle are congruent. And then also just a reminder of Theorem 22. It's about the perpendicular bisector, which is of a segment. It's a line that bisects and is perpendicular to the segment. And so Theorem 22 says if 2 points are each equidistant from the endpoints in the segment, then the 2 points determine the perpendicular bisector of that segment. So here is a segment, here's a point, here's another point, okay, here's another point. I could pick any one of these points as long as they're equidistant. Like that's equidistant. This one happens to be a midpoint, so it's also equidistant from the endpoints. And this point is equidistant from those. Any two of these points could be chosen to be the determining points to make a line that is the perpendicular bisector. So it bisects the segment, and it is perpendicular to the segment because each of these points is equidistant from the endpoints of the segment. Now, Theorem 23 says if a point is on the perpendicular bisector of the segment, then it is also equidistant. So I'll plop a point on this perpendicular bisector, and it will also be equidistant from the endpoints of that segment. And then finally, Theorem 24 says that if there's some other point that is also equidistant from the endpoints of that segment, then it lies on this line that is the perpendicular bisector. So we can extend this line on through it because we've just determined that it is also on the perpendicular bisector. So that's the lies on theorem, Theorem 24. So you need to just be familiar with those four theorems, 18, 22, 23, and 24. There's a way in which 22, 23, and 24 all kind of say the same thing in different ways. And you'll find that a lot with the theorems. So 4A, prove that the perpendicular bisector of a chord of a circle, this is a chord of a circle, any kind of line segment that connects two parts of a circle is called a chord. The largest chord is called the diameter. That's the one that goes all the way through the center and is the largest distance from one side of the circle to another. So prove that the perpendicular bisector of this chord must also pass through the center of the circle. So we've been given that it's circle O, so O is the center. We have been given that EF, also FE, is the, you can name it either way, is the perpendicular bisector line for AB. Okay. And then that's given. Then we can draw OA and OB because 2 points determine a line. That's an important little detail there in the proof. And then it says OA is congruent to OB. So OA is congruent to OB. And we need to choose which one of these. We're trying to figure out which theorem is best for the reason for statement 4. So all radii of a circle are congruent. If 2 points are equidistant, we don't know that they're equidistant. We're saying they are. We had to prove that. We don't yet know that they're on the perpendicular bisector, so we can't use 23 and 24 yet. So it's a circle. They all extend to the edge of the circle from the center of the circle. So it's Theorem 18. All radii of a circle are congruent. Now 4B continues to statement 5. Now we're saying FE passes through O. Well, O is equidistant from the endpoints. And we're trying to determine that this FE goes through it, that O lies on that FE is the perpendicular bisector and O is equidistant from the endpoints of the segment that's been that we're dealing with. So that leads us to Theorem 24. If a point is equidistant from the endpoints of the segment, then that point lies on the perpendicular bisector of the segment. So here's where we can apply that theorem. O is equidistant to the endpoints of the segment, so O will be on the same line that is the perpendicular bisector, which happens to be FE. And here we go, Theorem 24. Now, the last question says, okay, consider the proof in 1C and 1D. That should actually say 4A and 4B. I will have to fix that. How did the three parts of the strict procedure below get applied? They're called SP1, SP2, SP3, strict procedure 1, 2, and 3. How did they get applied? I'm really looking for your thoughts on this, not trying to catch anyone getting wrong answers, but I will say a few things about it. So prove that the line in question is the perpendicular bisector. So we've done that. That was an easy part because it was one of the givens. So SP1, and you can see SP1 is the statement that FE is the perpendicular bisector of AB. In other cases, you might have to do some work to prove it. Here it's given. So SP1 is simply given because FE is defined as the perpendicular bisector of AB. AB was the segment that was the chord. Okay. Strict procedure part 2. Prove that the point in question is equidistant from the endpoints of the same segment. Okay, so SP2 was shown by the fact that OA and OB were radii of the same circle, so they had to be congruent by Theorem 18. Okay, then so strict procedure 3, apply Theorem 24 to conclude that the point lies on the line. Well, how do we do that? So what we combine is the meaning that FE is the perpendicular bisector and that O is equidistant. So that combination is Theorem 24. So there is an existence of a perpendicular bisector. O is equidistant from the endpoints of the segment. So O has to be on the perpendicular bisector of that segment. SP3 is the culmination of the information before that there exists a perpendicular bisector called FE, or EF if you prefer, and that O is equidistant from the endpoints of the segment in question. That's AB, the chord AB. Okay, and therefore O is on that perpendicular bisector FE. By the way, there are later going to be theorems that this demonstrates that if you bisect a chord, then you are going to so bisecting a chord is going to make a right angle, of course, bisecting it from the center of a circle. And there are other applications to this that will come up. Okay, I hope that was helpful, and I will stop now.